Hey fellas, this is Andy. This is pretty much the beginning of the tutorial set that I'm making right now, and first things first, I wanted to talk about smoothing groups because that's a pretty big deal in game type work. So this model, or this polysphere, has a lot of polygons, and yet it's being smoothly shaded across the entire surface to make it look like a perfectly smooth sphere. And that's done with smooth groups. Um, Basically, you could turn that off and get more of a faceted look like this. The thing about this is that it's actually more expensive for the graphics card to render this geometry than it is to render the smooth version, which is kind of weird to me actually. Um, Basically, every time that you want to have a harsh edge, that's usually going to be extra cost for your graphics card to render it. Basically, this is talking about different types of splits, and having a lot of materials is expensive, having UV splits is expensive, and shading splits like smoothing groups. So, in this other tutorial that you can find on poopinmymouth.com, um, basically it's talking about how in order to make some harsh edges, you have to separate things out into different smoothing groups. And so I'm going to go ahead and show you how that kind of works. Like, I'll select a few faces. Whoops. Um, so here we go. I'll select a bunch of faces and I'll put them on a separate smoothing group. Oops. They're on smoothing group 2. So they're kind of their own thing. Basically, the way I understand it is that it's either smooth shading or unsmooth shading. It's basically on or off. And when you see it in Maya, where it's got like a normals set normal angle, this is kind of deceiving. Like, it's not basically depending on the angle of the surfaces next to each other, it will either make it smooth or it won't make it smooth. It's on or it's off. And so that's kind of how you have to do things. Like I can and I will put these. See that? I've got a smooth and then a sharp. So basically you can manipulate your smoothing groups to make the shading basically whatever you want. Sometimes it can be better to be using less smooth groups and actually bevel your object more, like add more tries in order to get a similar look. Here is, we'll try it here. Alright, for this one I'm going to use a chamfer. 3-segment chamfer. And take down this distance. Alright. And then basically we'll just add one 60-degree smoothing group and turn off that. Alright, so the difference between these two is not that noticeable. There is a slight bit of shading on this one that's like, it's getting darker at this corner, but the cost of this one is significantly less than this one, even though this one has more polygons. And the reason is there is, like, to achieve this look, whoops, of sharp angles, you need to have it, you need to have 3 smooth groups being used. Each smooth group is actually really expensive, and it's almost better to use a single smooth group with extra polygons. It just depends kind of on the situation. Like on a system where you have really harsh memory limitations, then it might be in some cases better to go with harsh edges like this and lower poly, just because more vertices means more memory. But for this, like if you're working with a PC system, then go ahead and add more vertices because it's less cost to the GPU to render a single smooth group mesh. I don't know exactly why that is true, but I'll show you some examples in some games where they're using less smooth groups just because it saves performance. Here's Call of Duty, and right here, this cylinder sticking out, you would think that this would be a harsh edge right here, but it's not. It's actually some extra polygons. Like, if we just make a cylinder really quick, and yeah, we'll convert it to poly and extrude the top and scale that. Basically, you would think they wouldn't have it shaded like this, but they do. Another example is in Left 4 Dead here, where they have these pieces, and it's like, see, there's a light over here, and it's shading these pieces that you would think would only be lit in a certain spot, but it's like a whole gradient across the entire thing, just because they added as few smooth groups as possible to it. So, now that you guys know that smooth groups are kind of expensive, just be mindful of that. And if you're making harsh, sharp edges, then just, make situation by situation call as to whether to add more polys or split up the smoothing groups.